Hello and welcome. My name is Maida. I use the pronouns she and her, and I will be your moderator today for MOS Live, Ask a Scientist Exploring Mars. Now, today, as your moderator, I will be fielding your questions. That means that you can look at that Q&A tab at the bottom of your screen and type in any question relating to Mars, and I will be asking that to our panelists today. Now, before we do meet our panelists, I would just like to let you know that if you would like to see captions today, you can go ahead and click the closed captioning button at the bottom of your screen and select Show Subtitles. And now, with all of that out of the way, I would like our panelists to introduce themselves and let me know what is your favorite thing about Mars.
Hi, everyone.
I will be going away.
My name is Eric. My pronouns are he and him. And my favorite thing about Mars is really looking back a long time in history, about 1 billion years. Mars used to have water, a lot of water, like maybe oceans of water. And what just came out this last week was that water's still there. It's locked up in rocks. It's not going to be lakes again anytime soon. But Mars lost its water, kind of. And it's kind of still there. And it's interesting to think we can go explore and find that out.
Hello, my name is Matt. My pronouns are he and him. And one of my favorite things about Mars is that as weird and as alien it is, there's one thing that makes it very similar to Earth, which is that it has a day almost exactly as long as ours.
Those are two really cool things about what is arguably my favorite planet. I also love Mars. I would say that probably my favorite thing about it is just how much it changed for some of its history and then how much it hasn't since. So we kind of have this snapshot of a world that has gone through all of these changes that Earth has never really gone through. And it teaches us a lot about how planets can change and evolve.
That's awesome. And well, we don't have questions just yet. Like I said, if you guys would like to put in questions, you can do so at the Q&A tab at the bottom of your screen. But I heard that we just had a new mission go to Mars. Could you guys tell me a little bit more about that?
Yeah, absolutely. So the mission in question is, this one right here. It's called the Perseverance rover. The Perseverance rover is a very similar design to the Curiosity rover, which landed in 2012 on Mars and is still driving around doing science. So now there are 2 active rovers on Mars, and Perseverance landed and has already, in its first month, spent some time doing some really cool science. It has some experiments that are going to start soon, and it has a really cool sort of set of awesome things that it's going to be doing. So that is one of the things that has got us thinking about Mars right now. It's Mars season.
Awesome. And so speaking of a mission that just got to Mars, what are those challenges in getting to Mars?
So Mars is pretty far away. It's about 100 million miles sometimes. It's the same distance that Earth is from the sun. And it takes a long time. It takes about 6 months to get a mission all the way out there. By the time you get out there, to send a radio signal to Mars takes sometimes 15 minutes or sometimes almost an hour. So your mission has to do everything on its own in terms of getting down to the surface. The biggest challenge is going from fast enough to get there in a human lifetime, in a couple months actually, to slowing down enough to land gently on the surface and not break. So you have to have this whole sequence of parachutes and heat shields and retro rockets and a sky crane lowering it down. All that has to happen on its own. You don't have someone back at NASA pushing a button that says, okay, now deploy the parachute. So really big challenges that are faced, and challenges that have not been able to be overcome by many Mars missions, which are now kind of just wreckage on the surface of Mars. We're like maybe now 55% successful at landing stuff on Mars that we've tried to. But Perseverance landing went great, picture perfect. Check out the video of that landing. It's awesome, and it's real. It's not computer generated. And yeah, so far, challenge is passed.
All right. No, go ahead, Matt. Sorry.
And while Eric was specifically talking about robotic missions, one of the challenges for the future, if we can ever send people there, is simply the amount of materials that we'll need to bring with us. Because the context is the longest space mission we've done so far are the Apollo missions to the moon, which were about a week, a few days out, a couple days there, a few days back. this would be a matter of months. So all the food you need to bring, all the water you need to bring, oxygen that could somehow be circulated, safety, all the materials for living on the surface and exploring it, all of that stuff would have to be gotten into orbit in the first place, manhandled through space, which is a lot of effort, and then somehow gotten down. So the challenges of going there with people will be so much more dramatic than with robots, which is one of the reasons it'll take a while.
All right, so you mentioned some of the challenges of humans going to Mars, and somebody wants to know, would radiation be another issue if we ever got there, and would underground shelters be considered protection or one of those options?
A great question and really good observation. Absolutely. Radiation is always a concern in space. Pretty much once you leave Earth's atmosphere, Earth has a magnetic field that does a really good job at protecting us from from the enormous amount of radiation that is in space. And so just like Matt was talking about with that long journey to get to Mars, that whole time, people would have to be shielded from radiation while they're in space. So that's already a challenge. It's one that we've discussed and talked about quite a bit already, because as Matt mentioned, even as those Apollo astronauts went to the moon, they did have to deal with a lot more radiation. And so we do know a little bit about how to protect from radiation in space. And there are cool new solutions with some of the next generation spacecraft that NASA is building for humans, including the Orion capsule. In terms of radiation on Mars, yes, you're right again. Also a problem on Mars. Mars has a very weak magnetic field, and so a lot more radiation from space gets to the surface of Mars. So yeah, if we wanted to have people living on Mars, radiation shielding would be super important. Underground is a possibility. We don't know as much about the sort of underground system of Mars. We don't know a lot about if there's like a lava tube tunnel system like there is on the moon that could make being underground a little bit easier on Mars, but that is one of the solutions people have put forward, is that radiation from space could be a big problem. Maybe just going underground is the way to get past it.
Wow, it sounds like there are so many challenges to getting humans to Mars. But going back to Perseverance for a little bit, somebody wants to know, has Perseverance started collecting data yet, or are there pictures that people can see? And if so, where can they find these?
So the best place to check out is NASA's website. Every picture, everything that comes back from these rovers is public domain, which means they don't hide it. You don't have to pay for it. It just gets put on NASA's website. So they tend to take the best ones and make press releases and articles about them. Just before we started, there was a new one I hadn't seen where you could see a dust devil, just kind of like wind making dust into a teeny tiny little tornado like phenomenon that kind of like went by in the background and got snapped in a couple pictures. There's been awesome video of the landing sequence, looking down, looking back up at the sky crane as it flew away. So NASA's website, and just typing in things like images from Perseverance and finding articles in science websites will be the best place to look for it. And they've been really cool ones. And we're excited for the next series that are going to come back in the next couple weeks, because they're going to be from a little helicopter.
So exciting. Okay, so speaking of Perseverance, how long did it take to build Perseverance, or to build something like that?
That's a really good question, because it sort of has to start with, well, when did the idea begin, right? Perseverance is based on the design of Curiosity, and Curiosity was first pitched back in like 2002. So in a way, it's been an idea for a long time to have this large scale rover. That's something that I think a lot of people don't know. It's easy to look at, this sort of device out of context and think that it's like the size of maybe like a golden retriever. It's not. It's the size of like an SUV. It's a pretty big device. The wheels alone are like 2 feet tall. So that means that the idea of having this enormous, basically rolling science laboratory, which is the original name of the Curiosity mission, was the Mars Science Laboratory. And Perseverance is very much a continuation in that trend. So Curiosity launched in 2012 and landed also in 2012, whereas Perseverance launched in 2020 and landed in 2021. And so the actual construction of Perseverance took about the same time as Curiosity. So it took about 3 years of actual engineers on site building this in the Jet Propulsion Laboratory. But the design is not a new one. And they also made a lot of improvements on the design of Curiosity. Those design improvements have been in progress for a long time. So like most pieces of the engineering process, you know, the whole design process of engineering starts and goes through lots of different iterations of testing and failure and redesigns and things like that. So you could say it's been nearly 10 years, but it definitely kicked into high gear starting around 2016.
Wow, that's a long time. And I had no idea that these rovers were that big. Thank you for putting me up, Sarah.
They're huge.
So you've mentioned Curiosity a few times, and somebody wants to know, what's the difference between Curiosity and Perseverance?
So basically, Perseverance is the same body of the rover, and there's upgrades to some of the things that didn't work so well in Curiosity, and then all the science instruments are brand new, looking at some of the same things, but with better equipment, better cameras, better drills, better lasers to zap rocks and figure out what they're made of. And then a couple other experiments that are going to do new things. One of them is going to try to take air on Mars that's mostly carbon dioxide and do a little chemical reaction and turn it into pure oxygen, which would be great for humans to be able to do one day so that they could breathe without having to bring oxygen all the way from Earth. But oxygen is also a kind of important thing for launching rockets. And so if we could make rocket fuel from what we found on Mars instead of bringing it with us, that would be really important. All the experiments are like that. They're updated, they're brand new, they're going to answer questions that kind of Curiosity gave us questions, and Perseverance is going to try to answer them with these new things. And then as far as the body of it, a lot of it is the same. Some of it is even spare parts from Curiosity that were, kind of lying around NASA, and they just built it into a new rover. Some of the things that didn't work out on Curiosity were the wheels. If you've ever seen pictures of Curiosity's wheels, they look awful. After driving around for 10 or 15 miles, however long it's gone now, they really got banged up. And so I actually talked with the lead mobility engineer for our podcast called Pulsar, and was able to have him tell me how they tested the wheels of this new rover to make sure that they would be up to date. You can hear all about it in the episode if you search for it on our website. It's called Who Gets to Drive the Mars Rover? But basically they went out to the Mars yard, tested out the wheels of the new design. They ran it for like miles and miles, and the things that they were testing the wheels on started to wear down. They put Curiosity's wheels on the same track and they broke after about 50 feet. And so he called the wheels bomb proof. So that's a big improvement. That's definitely not going to be an issue.
Wow, that's a drastic change. So going back to maybe some of the basics on Mars, does Mars have an atmosphere? Is it similar to Earth's? And I know you mentioned a dust devil, so it must have some sort of weather?
Let's start with the atmospheric contents. Mars does have an atmosphere, but as Eric mentioned earlier, it's made almost entirely of carbon dioxide gas, which is toxic to humans. There's very little of the nitrogen and the oxygen that make up almost all of Earth's atmosphere. There's also not very much of it. It has a very thin atmosphere. So any people that would want to be out on the surface of Mars would not only need radiation protection, but they'd need to be in some sort of a pressurized suit that could protect them from that low pressure environment, which does ghastly things to your blood, as well as keeping you warm, because Mars is also appallingly cold, and also giving you oxygen to breathe. Another tricky thing about the lack of oxygen, it also ties into what somebody was asking earlier about radiation. One of the things that helps to protect Earth from some kinds of radiation, like ultraviolet light, is our famous ozone layer. And ozone is a temporary unstable gas that's made of oxygen. So no oxygen, no ozone. So in addition to the stuff that would be getting through its non-existent magnetic field, there's also not that additional screen. So yeah, it's a rough atmosphere. It almost certainly had something more significant in the past, because the past rovers have come up with ample evidence that Mars had liquid water on its surface. There's erosion features and features that suggest water-filled plains. And you wouldn't be able to have liquid water on Mars currently for very long with such a thin atmosphere. The Mars would vaporize very rapidly because there's just not enough to push on it to keep it as a liquid. But what it was in the past is something we still need to find out.
That's so interesting. And so, like I said, you mentioned somebody mentioned a dust devil. So does that mean that there's wind, there's weather, there's, I guess not rain because there's no water, but...
Yeah, Mars has what I think is one of the absolute coolest weather phenomena in the entire solar system, which is global dust storms. The entire surface of Mars periodically, it's really big ones come around every 3 years, 3 Earth years, and smaller ones around every 1.5 years. There are these, that basically just sort of the dust on the surface of Mars gets kicked up by these windstorms that come and they push dust up into the atmosphere. The entire atmosphere of Mars kind of puffs out with these dust storms. This was actually one of the first observed phenomena on Mars because the first orbiter that we sent to Mars arrived during a global dust storm, and it was a pretty unique experience to be able to study. Now, yes, there are winds on Mars, but anyone who's ever seen The Martian, and there's like that part at the beginning that's really exciting when the wind comes and blows the rocket over, that wouldn't happen. Just like Matt was saying, the atmosphere is so thin that even though there is wind, it could never really blow hard enough that you'd be able to like feel it or that it could like knock something over. That's not really a concern on Mars. So because the atmosphere is so thin, those weather phenomena tend to be pretty different from what we see here on Earth, except in environments like high deserts. So the most comparable weather to Mars, weather phenomena on Mars, are something like the Atacama Desert in Chile, where you see these dust devils forming, you can see these big dust clouds get kicked up, but there is not rain on Mars. There are clouds on Mars, but more like a generally cloudy sort of atmosphere. So it's very different from Earth in a lot of ways, but has some pretty cool phenomena all of its own.
Awesome. And so we've mentioned a few times what the challenges would be for humans to get to Mars. And so I'm really curious, in the future, could humans get to Mars? And if so, what would that timeline look like?
1990s, no wait, 2000s, no wait, 2010s, sometime in the 2030s. And actually, now that it's 2021, 2030s is like late 2030, maybe 2039.
Push it, yeah.
I've been starting to tell people 2040s, realistically, optimistically, is when the earliest chance that I think that people could get to Mars. We just need to do a lot more to make sure that the astronauts are going to stay safe, that they're going to be able to operate without the radiation increasing their risk of things like cancer beyond a certain point. They have to be able to have closed systems. We have good experience of that with the International Space Station. That's an orbiting laboratory that has astronauts go up for 6 months or a year at a time. And they have a pretty closed system where they recycle drinking water and urine, and they have made a lot of progress on recycling the air, but they get regular deliveries of supplies, food from the ground. So if we need to bring all of that with us, it's a really huge undertaking. And it's also not unpolitical by its nature, by the size of the project. You have to have enough support to have enough money to send enough rockets to Mars to sustain the whole mission. And so that needs to materialize. If we have a really big push, then we'll be able to do that. And we're planning right now for NASA to go back to the moon and set up a permanent moon base there. And so if we can really, find out more about what the advantages that would be and the benefits to all of people, not just the ones who get to go on the mission, but figuring out how to recycle water better is going to benefit everyone on the Earth. Figuring out how to make batteries smaller and more efficient is going to benefit everyone. So there are these benefits that hopefully we can kind of leverage to say, it's worth going to Mars and we should get there soon.
And trust me, when you're drinking at some point somebody else's pee, you definitely want that recycling to work real well.
Yes, I can imagine. I definitely would. Okay, so we said that Mars has global dust storms. Does it have other types of storms? For instance, is there lightning on Mars?
Okay, correct me if I'm wrong. I'm fairly sure that lightning has definitely been observed on Venus, Jupiter, and Saturn. I don't think it's been observed on Mars. I'm not 100% sure about that. There could potentially be some lightning in the dust storms, but I don't know if we've gotten enough. We've had orbiters around Mars for a long time. And my instincts are that there could be occasional electrostatic activity in the atmosphere of Mars, but nowhere near the level of lightning that we observe on planets that have much thicker atmospheres, like Venus, Jupiter, and Saturn, where all of those clouds that are roiling that really are sort of dominate the planet's surface. You can't even see the surface because there's such a thick atmosphere. That's where we tend to observe a lot of like upper atmospheric lightning and things like that. We've never observed like a lightning strike on Mars, for example, something striking. That'd be crazy. Statistically, that'd be pretty crazy to observe. But yeah, we haven't observed like rainstorms, thunderstorms, things like that on Mars.
Interesting. Okay, and so I know that at least on Earth, the tilt of the Earth kind of affects a lot of things, including our weather and our seasons. Does Mars have a tilt like that?
It does. And remember how I mentioned at the beginning that our Mars's rotation is almost exactly as long as Earth's rotation. It's a little over 24 hours. Mars's tilt of its axis compared to its orbit is almost exactly the same as Earth's as well. Now, that might make it sound like our seasons would be very similar to Mars's, because Earth's seasons are primarily driven by the tilt of its axis. But Mars has one other thing going for it. While Earth, as it goes around the sun, doesn't really change its distance all that much. It changes by about 3 million miles from being closest to farthest, which sounds like a lot, but for 93 odd million miles, it's really a pretty small amount. So Earth never really changes significantly how far it is from the sun. Mars, on the other hand, has a significant difference in how far away it is. It has an orbit that's much more shaped like an ellipse or an oval. So during, I believe it's the Southern Hemisphere winter, when it's farthest away, in addition to the tilt of the axis, its farther distance dramatically increases the effects of the southern winters on Mars. So if you do ever travel there, buy northern real estate.
Or there's a whole really great region where we landed a lander a couple years ago called the InSight lander. It's called the Elysium Planitia, which means the heavenly prairies. That's like right at the equator of Mars. That's where I built my summer home, I think.
Well, I'll start planning my Mars holiday now. Get those reservations in. So Mars is really, really far away. And that means that Perseverance is pretty far away right now. So how are we getting information from Perseverance?
So luckily, Perseverance is not the only robot exploring Mars right now. We have close to a dozen now. I think it might be 11. We have the InSight lander, which doesn't move. We have the Curiosity rover, it's moving around. And honestly, I lost count because we keep adding robots. I think we have 8 or 9 orbiters going around Mars, maybe 7 or 8 active ones. But those orbiters are doing their own science missions. They're studying the atmosphere of Mars. They're making amazing maps. One of them has a camera that could take a picture of a loaf of bread on the surface of Mars. It's so beautiful. We have maps of that detail, which help us land on Mars in like safe places instead of in the middle of a crater or on a volcano or something. But those orbiters also have a second job, and that is kind of as relay stations. So Perseverance itself doesn't have a big satellite dish on it. You won't see a big communications relay because all it has to do is get a signal up to those satellites, which do have really big dishes. And those are the ones that beam back to Earth. So we get everything going through those intermediaries. They study the atmosphere and they take their own readings. And then they take all the data from the rovers on the ground and then send it back to Earth. And that, again, takes a really long time because at the speed of light, Mars is still 15, 30, 45 minutes away. And so to drive the rover, you need to tell it what to do and then have it drive itself. And so that was another episode of our podcast that we did, but like who gets to drive the Mars rover and how does that work? Turns out the rover can drive itself a long time for pretty well. You can tell it to pick out a spot and it can drive, it can avoid obstacles, it can take pictures, its internal computers can manage that. So all that happens kind of autonomously. So the answer to who drives the Mars rover sometimes is the Mars rover.
That's pretty cool. Okay, so probably the last question that we have time for is, how long will Perseverance be on Mars? Do we have plans on Perseverance coming back?
Yeah, short answer, forever. But Perseverance, we have never brought anything back from Mars. Everything that we have ever sent to Mars is still on Mars or in orbit around Mars. Getting something back from Mars would be about as hard as getting something to Mars, and we do not have a NASA on Mars. We don't have a Jet Propulsion Laboratory. We don't have Cape Canaveral. We don't have a lot of the things that we really like to have when it comes to launching rockets. So we've never launched anything from the surface of Mars to come back to Earth. Perseverance's mission, however, so its primary mission is for 1 Martian year, which is a little less than 2 Earth years. So it is going to, that's it. That's how long it is like already set and ready to go for that much time. But based on our experience with other rovers, like for example, Spirit and Opportunity were arrived in 2004. They had a 90-day primary mission, and Opportunity only officially was declared mission complete in like 2018. So this is something that happened. They last a really long time sometimes. And just like Eric was saying, with all of that work that they've done to improve the design of Curiosity, which Curiosity has already lasted 8 years, it's a pretty good chance that unless something really bad happens to Perseverance, that is a rover that can probably keep working for over a decade. So we should hopefully be able to get lots and lots of really good science out of this thing.
Wow, well, this has been so much fun. Thank you guys so much. I personally learned a lot about Mars since I didn't know a whole lot, but I think it is time for you guys to say goodbye.
Bye. Thanks for coming.
Bye, everyone.
Awesome. And so thank you guys all for joining us today. I'm sorry that we didn't get to all of your questions, but they were great. And thank you guys so much for asking those questions. Now, if you want to see what we have in store or what we have offered, you can go check us out at mos.org/mos@home to see all of our virtual offerings. And if you would like to support the Museum of Science, go ahead and visit us at engage.mos.org/welcome. Thank you guys so much for joining us, and have a wonderful rest of your day. Bye.